In the vast expanse of the cosmos, where stars are born and galaxies collide, there exists a breathtaking dance, a delicate interplay of light and shadow that shapes the very fabric of the universe. Picture, if you will, a nebula glowing with vibrant hues, its light piercing through the darkness, only to be swallowed again by the void. This is the cosmic ballet of interstellar echoes, where light and shadow are not just opposites, but partners in an eternal rhythm. They whisper secrets about the origins of our universe, the birth of stars, and the fate of galaxies. But what do these echoes truly reveal? What mysteries lie hidden in the contrast between brilliance and obscurity? Today, we embark on a journey to unravel the secrets of this cosmic dance, exploring how light and shadow shape the universe and what they can tell us about its past, present, and future. From the birth of stars to the edges of black holes, we'll discover how these forces shape the cosmos and, perhaps, our understanding of existence itself. In the grand tapestry of the universe, light and shadow are more than mere opposites. They are the fundamental forces that compose a cosmic symphony. Light, with its radiant energy, acts as the melody, illuminating the structure of galaxies, tracing the birth of stars, and revealing the intricate paths of cosmic dust. It allows us to witness the universe's most awe-inspiring spectacles, from the fiery glow of supernovas to the shimmering arms of spiral galaxies. Yet, shadow plays an equally vital role, weaving its harmony into the fabric of existence. It cloaks the mysteries of black holes, conceals the birthplaces of stars within dense nebulae, and creates the contrast that gives the cosmos its depth and dimension. Together, light and shadow form an intricate dance, a symphony that echoes across the vastness of space and time. These interstellar echoes are not just fleeting moments, but enduring imprints, remnants of cosmic events that shape the universe on scales both unimaginably large and infinitesimally small. They ripple through galaxies, influencing the formation of stars and planets, and even bending the flow of time itself. Imagine for a moment the light from a star that has long since died, still reaching us across billions of light years, or the shadow cast by a black hole, warping space-time and challenging our understanding of reality. These echoes are the universe's way of speaking to us, revealing its history while hinting at its future. But where does this cosmic symphony begin? What sets light and shadow into motion, creating the echoes that shape the universe as we know it? To answer these questions, we must journey back to the very origins of the cosmos, to the moments when light first emerged from the primordial darkness and shadow began to carve out the boundaries of existence. It is here, in the birth of the universe itself, that we find the first notes of this eternal symphony, a story waiting to be uncovered. The story of light begins with a single, explosive moment, the Big Bang. In the earliest moments of the universe, there was no light, only a seething sea of energy and particles. But as the cosmos expanded and cooled, something extraordinary happened. Photons, the fundamental particles of light, were born, flooding the universe with its first glow. This primordial light, known today as the cosmic microwave background, still permeates the cosmos, a faint echo of that initial burst of creation. It's like a cosmic fingerprint, a snapshot of the universe in its infancy, and it holds clues to how everything began. But light didn't just illuminate the universe, it shaped it. As these early photons traveled through space, they interacted with matter, pushing and pulling particles, and setting the stage for the formation of the first stars and galaxies. This was the dawn of structure in the cosmos, a time when light began to carve out the pathways that would lead to the universe we know today. Yet, even in this early glow, shadow played a crucial role. dense regions of matter absorbed and scattered light, creating pockets of darkness that would later become the birthplaces of stars. Fast forward billions of years, and we arrive at stellar nurseries, vast clouds of gas and dust where new stars are born. These regions are both radiant and mysterious, filled with the potential for new light. As gravity pulls gas and dust together, these clouds collapse, igniting nuclear fusion and giving birth to stars. The light from these newborn stars pierces through the surrounding darkness, illuminating the nursery in brilliant hues, but even here, shadow persists. Thick clouds of dust obscure much of the light, creating intricate patterns of brilliance and obscurity. It's a reminder that light and shadow are inseparable, each giving meaning to the other. In these nurseries, shadow isn't just an absence of light, it's a sculptor. The dense regions of gas and dust block light, but they also create the conditions for new stars to form. Without these shadows, the delicate balance of pressure and temperature needed for star formation might never occur. It's a cosmic dance of creation and concealment, where light and shadow work together to bring new worlds into being. As we marvel at the beauty of these stellar nurseries, we're reminded that the story of light and shadow is far from over. The stars born in these dark, dusty regions will go on to shape the cosmos in ways we're only beginning to understand. But what happens when these stars reach the end of their lives? How do light and shadow continue to influence their fates? That's where our journey takes us next, into the life cycles of stars, where the interplay of light and shadow reveals even more about the universe's grand design. Every star in the universe has a story, a tale of creation, endurance, and sometimes dramatic transformation. From the moment a star ignites in the heart of a stellar nursery to its final breath, light and shadow are its constant companions, shaping its journey in ways both beautiful and profound. The story begins with a star's birth, a moment of dazzling brilliance. Deep within a cloud of gas and dust, gravity pulls material together, compressing it until the core becomes so hot and dense that nuclear fusion ignites. Suddenly, light bursts forth, cutting through the surrounding darkness like a beacon. This is the star's debut, a radiant announcement of its arrival in the cosmos. For millions or even billions of years, the star will shine steadily during its main sequence phase, burning fuel in its core and illuminating its corner of the universe. It's a time of balance, where the star's outward pressure from fusion counteracts the inward pull of gravity, creating a stable glow that defines its prime. But even the brightest stars cannot shine forever. As they age, their fuel begins to run low, and the delicate equilibrium starts to falter. For smaller stars, this decline is gradual, a slow dimming into a cooler, redder phase. But for massive stars, the end is far more explosive. When these giants can no longer sustain fusion, their cores collapse under their own weight, triggering a cataclysmic supernova. In an instant, the star's light becomes a blinding flash, outshining entire galaxies. The surrounding darkness is momentarily shattered, but it doesn't disappear. Instead, it takes on a new form, a shadow cast by the remnants of the star itself. In the aftermath of a supernova, what remains depends on the star's original mass. For some, it's a neutron star, a dense, spinning remnant that pulses with light like a cosmic lighthouse. For others, it's a black hole where gravity is so intense that not even light can escape. Here, shadow reigns supreme, creating a region of spacetime so warped that it defies our understanding. Yet even in this darkness, light finds a way to leave its mark. Around black holes, swirling disks of superheated gas glow brightly, their light bending and twisting as it tries to escape the gravitational pull. These phenomena are more than just remnants of destruction, they are cosmic echoes, reverberations of the star's final moments that continue to shape the universe. Through these life cycles, light and shadow reveal the duality of existence, creation and destruction, brilliance and obscurity. They remind us that even in the darkest corners of the cosmos, there is always a glimmer of light, and even the brightest stars are shaped by the shadows they cast. As we reflect on these stellar journeys, we begin to see light not just as a force of illumination, but as a cosmic messenger. It carries with it the stories of stars, galaxies, and the universe itself, traveling across vast distances to reach us. In the next part of our journey, we'll explore how light serves as this universal storyteller, carrying secrets from the farthest reaches of space and time. What mysteries does it hold, and what can it teach us about the cosmos? The answers lie in the light that journeys across the universe, bridging the gap between the distant past and our present understanding. Light is more than just a radiant force, it's a cosmic messenger, carrying the whispers of the universe across unfathomable distances. Every beam of light that reaches us, whether from a nearby star or a galaxy billions of light years away, holds a story. It's a story encoded in wavelengths, frequencies, and colors, waiting to be decoded. But how does light transmit these secrets? To answer that, we must first understand the electromagnetic spectrum, the vast array of light that stretches far beyond what our eyes can see. The electromagnetic spectrum is like a cosmic library, filled with volumes of information written in different forms of light. At one end, there's visible light, the rainbow of colors we're most familiar with, from the reds of a sunset to the blues of a clear sky. But beyond this lies a world of invisible light, each type revealing a different chapter of the universe's story. Infrared light, for example, shows us the heat radiating from distant stars and galaxies, while ultraviolet light uncovers the energetic processes happening in the hearts of stars. X-rays pierce through the shroud of cosmic dust to reveal the violent collisions of neutron stars and the swirling chaos around black holes. And radio waves, the longest wavelengths of all, carry signals from the earliest moments of the universe, offering glimpses into its infancy. Each type of light acts as a unique lens, allowing us to see the cosmos in ways that would otherwise be impossible. Take, for instance, the search for exoplanets, worlds orbiting distant stars. When astronomers look for these distant worlds, they often rely on shadows. As an exoplanet passes in front of its star, it casts a faint shadow, dimming the star's light ever so slightly. This tiny dip in brightness is like a cosmic fingerprint, revealing the planet's size, orbit, and even the composition of its atmosphere. Shadows, in this sense, are not just absences of light, but powerful tools for discovery. But the story doesn't end there. Light also carries echoes of the universe's most dramatic events. When a star explodes in a supernova, it sends out a burst of light that travels through space, carrying with it information about the star's composition, energy, and the forces at play during its final moments. Similarly, the light from distant galaxies holds clues about their motion, helping us understand how the universe is expanding and evolving. These interstellar echoes, encoded in light, are like cosmic time capsules, preserving the history of the universe for us to uncover. Yet, light is only part of the story. Shadows play an equally vital role in shaping our understanding of the cosmos. They reveal the presence of objects we can't see directly, from the dense clouds of dust in stellar nurseries to the event horizons of black holes. Without shadows, the universe would lack depth and contrast, its secrets hidden in a uniform glow. Together, light and shadow form a dynamic partnership, each enhancing the other's role in unveiling the mysteries of the universe. As we continue our journey, we'll explore how shadows shape some of the most profound cosmic phenomena, from the gravitational lensing of light around massive objects to the eerie silhouettes of galaxies colliding in the depths of space. These shadows are not just passive observers, but active participants in the cosmic dance, shaping the universe in ways we're only beginning to understand. What secrets do they hold, and how do they influence the grand tapestry of existence? The answers lie in the interplay of light and shadow, a partnership that continues to reveal the universe's most profound truths. In the grand theater of the cosmos, shadow is not just the absence of light. It is a canvas, a medium through which the universe paints its most enigmatic masterpieces. Far from being a passive void, shadow is an active force, shaping the way we perceive and understand the cosmos. It reveals what light cannot, uncovering hidden details and sculpting the fabric of space itself. From the fleeting silhouettes of planets during an eclipse to the vast, mysterious voids between galaxies, shadow is an artist, crafting beauty and mystery in equal measure. Consider, for a moment, the elegance of a solar eclipse. As the moon passes between Earth and the Sun, it casts a shadow that sweeps across the planet, momentarily cloaking the day in darkness. But this shadow does more than obscure, it reveals. In the fleeting moments of totality, the sun's corona, normally hidden by its own brilliance, becomes visible, a delicate halo of plasma dancing in the void. Here, shadow acts as a magnifying glass, allowing us to see what would otherwise remain invisible. It's a cosmic paradox, darkness illuminating the unseen. Beyond eclipses, shadows play a crucial role in uncovering the secrets of celestial bodies. When a planet transits its star, it casts a shadow that astronomers can detect from light years away. This shadow, though faint, carries invaluable information revealing the planet's size, atmosphere, and even potential signs of life. In this way, shadow becomes a tool for discovery, a way to peer into the unknown and uncover the universe's hidden truths. But the artistry of shadow extends far beyond individual objects. In the vast expanses between galaxies, shadow takes on a more profound role. These cosmic voids, regions of near-total darkness, are not empty spaces but intricate structures that shape the universe on the largest scales. They are the negative spaces in the cosmic tapestry, defining the boundaries of galaxies and clusters while hinting at the presence of something even more mysterious: dark matter. Dark matter, though invisible, casts its own kind of shadow. It doesn't absorb or block light in the traditional sense, but its gravitational influence bends and distorts the paths of light traveling through space, a phenomenon known as gravitational lensing. This cosmic trick of the light reveals the presence of dark matter, allowing us to map its distribution and understand its role in shaping the universe. Here, shadow becomes a detective, uncovering the unseen forces that govern the cosmos. Just as an artist uses contrast to bring depth and dimension to a painting, the universe uses shadow to reveal its most profound mysteries. The interplay of light and darkness creates a dynamic balance, a cosmic chiaroscuro that defines the beauty and complexity of existence. From the delicate silhouettes of planets to the sprawling voids between galaxies, shadow is a testament to the universe's artistry, a reminder that even in the darkest corners, there is meaning and purpose. As we marvel at the elegance of cosmic shadows, we're left with a tantalizing question: what lies beyond the darkness? What secrets are hidden in the unseen realms of the universe? In the next part of our journey, we'll venture into the enigmatic world of dark matter and dark energy, the invisible forces that shape the cosmos on the grandest scales. These mysteries, cloaked in shadow, hold the keys to understanding the universe's past, present, and future, a story waiting to be unraveled. Beyond the visible stars and swirling galaxies lies a realm of cosmic mystery, one that defies our senses and challenges our understanding of the universe. This is the domain of dark matter and dark energy, two invisible architects shaping the cosmos in ways we're only beginning to comprehend. Together, they make up over 95% of the universe, yet they remain hidden, detectable only through their subtle influences on the world we can see. Dark matter, though invisible, makes its presence known through gravity. It's the unseen hand that holds galaxies together, preventing them from flying apart as they spin. Without dark matter, the stars in a galaxy would drift away into the void, their motion unbound by the gravity of visible matter alone. But dark matter doesn't just hold galaxies together, it shapes the very structure of the universe. Vast webs of dark matter stretch across the cosmos, creating a cosmic scaffolding upon which galaxies and clusters form. These filaments of invisible matter guide the flow of cosmic gas and dust, orchestrating the birth of stars and planets on a grand scale. But how do we know dark matter exists if we can't see it? The answer lies in shadows, cosmic shadows cast by its gravitational influence. One of the most striking examples is gravitational lensing, a phenomenon where the gravity of massive objects bends the path of light. When light from a distant galaxy passes near a cluster of dark matter, it bends and distorts, creating a magnified, warped image of the galaxy behind it. These distortions are like fingerprints, revealing the presence of dark matter and allowing us to map its distribution across the universe. In this way, shadow becomes a tool, uncovering the hidden architecture of the cosmos. While dark matter holds the universe together, dark energy does the opposite. It pushes it apart. Discovered in the late 1990s, dark energy is the mysterious force driving the accelerated expansion of the universe. Unlike gravity, which pulls matter together, dark energy acts as a repulsive force, stretching the fabric of spacetime itself. This means that as the universe ages, galaxies are moving away from each other faster and faster, as if the cosmos is being pulled apart from within. The nature of dark energy remains one of the greatest puzzles in modern science. Some theories suggest it's a property of space itself, a constant energy woven into the fabric of the universe. Others propose it's a dynamic force, changing over time as the cosmos evolves. Whatever its true nature, dark energy is reshaping our understanding of the universe's fate, hinting at a future where galaxies may drift so far apart that they vanish from each other's view. The interplay between dark matter and dark energy is a delicate cosmic dance, one that shapes the universe on the grandest scales. Dark matter builds the structures, galaxies, clusters, and cosmic webs, while dark energy dictates their motion, driving the expansion that defines the cosmos. Together, they create a dynamic balance, a universe that is both structured and ever-changing. But what connects these invisible forces to the echoes of light and shadow we've explored so far? The answer lies in their influence on the visible universe. Dark matter's gravitational pull creates the shadows that reveal its presence, while dark energy's expansion stretches the very fabric of spacetime, altering the way light travels across the cosmos. These forces are the unseen choreographers of the cosmic dance, shaping the interplay of light and shadow that defines our universe. As we peer deeper into the mysteries of dark matter and dark energy, we're reminded of how much remains hidden. These invisible architects challenge us to rethink our understanding of the cosmos, pushing the boundaries of science and imagination. Yet, even in their obscurity, they leave traces, shadows, distortions, and echoes that guide us toward the truth. Our journey now takes us to the next chapter, where we'll explore how light and shadow interact on a galactic scale. From the collision of galaxies to the intricate dance of stars within them, these cosmic phenomena reveal the universe's complexity in ways that defy imagination. What secrets do these galactic echoes hold, and how do they shape the story of the cosmos? The answers await in the heart of the universe's most luminous and shadowy realms. Galaxies are the universe's grandest light shows, where the interplay of light and shadow creates scenes of unparalleled beauty and complexity. Picture the swirling arms of a spiral galaxy, each one a ribbon of starlight winding through the darkness. These arms, filled with billions of stars, gas, and dust, are not just static structures, they are dynamic, ever-changing landscapes. The light from young, hot stars illuminates the gas around them, painting the spiral arms in hues of blue and white. Meanwhile, shadow plays its part, cloaking the dense regions of dust and gas, adding depth and texture to the cosmic canvas. The result is a breathtaking dance of brilliance and obscurity, a galactic lightscape that captivates the imagination. Take, for example, the Andromeda Galaxy, our closest galactic neighbor. Its spiral arms stretch across the night sky, a tapestry of light and shadow woven over billions of years. Within these arms, pockets of darkness hide the birthplaces of new stars, while glowing nebulae mark the sites of stellar nurseries. These nebulae, like the Orion Nebula closer to home, are among the most striking features of any galaxy. Imagine a vast cloud of gas and dust, illuminated from within by the light of newborn stars. The gas glows in vibrant colors, red, pink, and gold, while the surrounding dust creates intricate patterns of shadow, adding layers of mystery to the scene. But these galactic lightscapes are more than just beautiful. They are also dynamic. The interplay of light and shadow within a galaxy reveals its history and evolution. The glowing regions of star formation tell us where new stars are being born, while the darker lanes of dust hint at the material that will one day fuel future generations of stars. Together, light and shadow create a living portrait of the galaxy, a snapshot of its ongoing story. The Orion Nebula, for instance, is a stellar nursery located within our own Milky Way. Its glowing clouds of gas are illuminated by the intense light of young, massive stars, while the surrounding dust creates dark filaments and knots that add depth and contrast. These shadows are not just aesthetic, they play a crucial role in the formation of stars and planets. Within these dark regions, gravity pulls gas and dust together, creating the dense cores that will eventually ignite into new stars. It's a reminder that even in the brightest parts of the galaxy, shadow is a vital force, shaping the cosmos in ways we're only beginning to understand. As we marvel at these galactic lightscapes, we're reminded that the universe is a place of constant change. The light we see today is the result of processes that began millions or even billions of years ago, while the shadows hint at the future, at the stars and worlds yet to be born. This interplay of light and shadow is not just a feature of galaxies, it's a fundamental part of how the universe works, shaping everything from the smallest stars to the largest structures in the cosmos. But what happens when the light and shadow within a galaxy give rise to something entirely new? What role do they play in the formation of planets, the building blocks of worlds like our own? These questions lead us to the next chapter of our journey, where we'll explore how light and shadow shape the birth of planetary systems, turning the raw materials of the cosmos into the diverse worlds that fill the universe. The story of these planetary cradles is one of creation and transformation, a tale written in the language of light and darkness. In the heart of a young star system, where chaos and creation intertwine, lies a cosmic cradle, a swirling disk of gas and dust known as a protoplanetary disk. This is where planets are born, and where the interplay of light and shadow takes center stage in shaping new worlds. Picture a star at the center, its light streaming outward, illuminating the disk like a spotlight on a stage. But within this glowing expanse, shadows emerge, dark patches where dust and gas block the light, creating pockets of coolness and calm. These shadows are more than mere absences of light. They are the architects of planetary systems, carving out the paths that will lead to the birth of planets. As the star's light bathes the disk, it heats the material closest to it, causing gas and dust to evaporate and disperse. But farther out, where the light grows dimmer and shadows dominate, the temperature drops. Here, molecules begin to clump together, forming tiny grains of dust that collide and stick, growing larger over time. These grains are the building blocks of planets, and the shadows are their sanctuaries, protecting them from the intense heat and radiation that could otherwise tear them apart. It's a delicate balance. Light fuels the star, while shadow nurtures the seeds of new worlds. Within these shadowed regions, gravity takes hold, pulling the growing clumps of dust and gas into larger bodies. These protoplanets, as they are called, continue to grow, sweeping up material from the disk and carving out their own orbits. The light from the star still plays a crucial role, warming the surfaces of these forming planets and driving chemical reactions that shape their atmospheres. But the shadows remain essential, defining the boundaries of these young worlds and creating the conditions for their surfaces to cool and solidify. Once formed, planets continue to be shaped by the dance of light and shadow. Take Earth, for example. Our planet's atmosphere, oceans, and even the seasons are all influenced by the balance between sunlight and darkness. The tilt of Earth's axis creates the changing shadows that bring us winter and summer, while the interplay of light and dark drives weather patterns and ocean currents. Even the colors of our planet, its blue oceans, green forests, and white clouds are the result of sunlight interacting with the surface and atmosphere, a testament to light's creative power. But shadows are not just passive observers in this process. They actively shape the climates and environments of planets. On worlds with thick atmospheres, like Venus, shadows are fleeting, as the dense clouds scatter light and create a uniform glow. On airless bodies, like the Moon, shadows are stark and unyielding, creating extreme temperature differences between light and dark. These contrasts influence everything from the formation of ice caps to the potential for life, making shadows a key player in the story of planetary evolution. As we explore these planetary shadows, we begin to see them not just as features of the cosmos, but as tools for discovery. By studying the way light and shadow interact on distant worlds, we can learn about their atmospheres, surfaces, and even their potential to support life. Shadows reveal the presence of mountains, canyons, and craters, while light carries the chemical signatures of gases and minerals. Together, they paint a detailed picture of worlds far beyond our own, offering glimpses into their histories and futures. This interplay of light and shadow is more than a cosmic phenomenon. It's a language, one that speaks of creation, transformation, and the delicate balance that defines our universe. As we continue our journey, we'll explore how this language is used not just to understand planets, but to explore the farthest reaches of space. From the shadows cast by distant moons to the light bending around black holes, these echoes of the cosmos hold the keys to understanding the universe's most profound mysteries. What secrets do they reveal, and how do they guide our quest to explore the unknown? The answers lie in the dance of light and shadow, a partnership that continues to shape the story of the cosmos. For centuries, humanity has looked to the skies with wonder, seeking to unlock the secrets of the cosmos. But to truly explore the universe, we've had to master the art of capturing and interpreting light and shadow, tools that have become the foundation of modern astronomy. From the earliest optical telescopes to the cutting-edge instruments of today, we've harnessed these cosmic forces to peer deeper into space than ever before, revealing a universe that is both breathtakingly beautiful and profoundly mysterious. The story of telescopes begins with light. When Galileo first turned his rudimentary telescope toward the heavens in the early 17th century, he opened a new window into the universe. By collecting and focusing visible light, he revealed details of the moon's surface, the phases of Venus, and the moons of Jupiter, discoveries that forever changed our understanding of the cosmos. Today, telescopes have evolved far beyond Galileo's simple design, but their fundamental goal remains the same: to gather light and bring the universe into focus. Modern telescopes, however, don't just rely on visible light. They span the entire electromagnetic spectrum, from radio waves to gamma rays, each type of light revealing a different aspect of the cosmos. Radio telescopes, for instance, capture the faint whispers of distant galaxies, while X-ray telescopes unveil the violent, high-energy processes around black holes and neutron stars. Even infrared light, invisible to our eyes, allows us to peer through cosmic dust clouds and witness the birth of stars. Each wavelength of light is like a different lens, offering a unique perspective on the universe's grand tapestry. But light isn't the only tool in our cosmic toolkit. Shadows, too, play a vital role in exploration. One of the most remarkable examples is gravitational lensing, a phenomenon where the gravity of massive objects bends and distorts light, acting like a natural telescope. When light from a distant galaxy passes near a massive cluster of galaxies, the cluster's gravity warps the light, creating magnified and distorted images of the galaxy behind it. These cosmic mirages are more than just curiosities. They reveal the presence of otherwise invisible dark matter and allow us to study galaxies that would otherwise be too faint to see. In this way, shadows become a powerful tool, uncovering hidden aspects of the universe. Even closer to home, shadows help us explore our own solar system. When a planet or moon passes in front of a star, it casts a shadow that astronomers can detect from Earth. These transits not only reveal the size and orbit of distant worlds, but can also provide clues about their atmospheres. By studying how starlight passes through a planet's atmosphere during a transit, scientists can identify the presence of water vapor, oxygen, and other gases, potential signs of habitability or even life. Shadows, in this sense, are not just absences of light, but gateways to discovery. The interplay of light and shadow has also led to one of the most exciting areas of modern astronomy: the study of interstellar echoes. These echoes are the remnants of cosmic events, supernova, collisions, and even the birth of stars, that ripple through space and time, carrying with them the history of the universe. By capturing and analyzing these echoes, astronomers can piece together the story of how galaxies form, how stars live and die, and how the universe itself has evolved over billions of years. It's a testament to the power of light and shadow as tools for exploration, revealing not just what the universe is, but how it came to be. As we continue to push the boundaries of exploration, one of the most intriguing mysteries remains: black holes. These enigmatic objects, where gravity is so intense that not even light can escape, seem to defy our understanding of the universe. Yet, even here, light and shadow play a crucial role. The event horizon of a black hole, the point of no return, casts a shadow against the glowing gas and dust that swirl around it. This shadow, captured for the first time in 2019 by the Event Horizon Telescope, is a direct window into the heart of a black hole, offering clues about its size, shape, and the extreme physics that govern it. The study of black holes is just one example of how light and shadow continue to guide our exploration of the cosmos. From the faintest glimmers of distant stars to the deepest shadows cast by the most massive objects, these forces shape our understanding of the universe in ways that are both profound and humbling. As we venture further into the unknown, one thing is clear: the dance of light and shadow will remain at the heart of our quest to uncover the secrets of the cosmos. Black holes are the ultimate cosmic paradox, places where light and shadow collide in a dramatic interplay that defies our understanding of space and time. At the heart of every black hole lies the event horizon, a boundary so powerful that not even light can escape its grasp. Beyond this point, the universe as we know it ceases to exist, swallowed by an inescapable darkness. Yet, paradoxically, black holes are also some of the most luminous objects in the cosmos, thanks to the swirling maelstrom of hot gas and dust that surrounds them. This glowing ring, known as the accretion disk, is where light and shadow meet, creating a spectacle that reveals the secrets of these cosmic enigmas. The accretion disk is a cosmic whirlpool of superheated material, spiraling inward at incredible speeds. As particles collide and compress, they release tremendous amounts of energy, glowing brightly across the electromagnetic spectrum. This light, however, doesn't travel freely. As it nears the event horizon, it bends and twists under the black hole's immense gravity, creating a mesmerizing dance of brilliance and darkness. The result is a shadow, a dark silhouette against the glowing disk that marks the presence of the black hole itself. This shadow, captured for the first time in 2019 by the Event Horizon Telescope, is more than just an image. It's a window into the extreme physics that govern these mysterious objects. The groundbreaking image of the black hole in the galaxy M87 revealed not just the shadow of the event horizon, but also the intricate structure of the accretion disk. The light bending around the black hole forms a bright ring, while the shadow at its center confirms the predictions of Einstein's theory of general relativity. This discovery was a triumph of human ingenuity, combining data from telescopes across the globe to create a virtual observatory the size of Earth. It's a testament to how light and shadow, when harnessed by science, can unveil the universe's most profound secrets. But black holes aren't just cosmic curiosities. They play a vital role in shaping the universe. Their immense gravity influences the motion of stars and galaxies, while their accretion disks can outshine entire galaxies, illuminating the cosmos with their brilliance. These phenomena are part of the broader tapestry of interstellar echoes, the remnants of cosmic events that ripple through space and time. By studying black holes, we gain insights into the forces that drive the universe's evolution, from the birth of galaxies to the fate of stars. Yet, for all we've learned, black holes remain shrouded in mystery. What happens beyond the event horizon? How do they influence the flow of time itself? These questions lead us to the next chapter of our journey, where we'll explore how light and shadow shape not just space, but time, a dimension as enigmatic as the black holes that warp it. What secrets lie hidden in the interplay of light, shadow, and time? The answers await, just beyond the horizon of our understanding. Time is not just a ticking clock, it's a cosmic dimension woven into the very fabric of the universe. And at the heart of this relationship between time and the cosmos lies light, the ultimate messenger of the universe's story. When we look up at the stars, we're not just seeing points of light, we're peering into the past. The light from distant stars and galaxies takes years, centuries, even billions of years to reach us. In a very real sense, light is a time traveler, carrying with it the history of the universe. But how does light shape our understanding of time, and what can its journey tell us about the nature of spacetime itself? The concept of spacetime, first introduced by Albert Einstein, revolutionized our understanding of the universe. Spacetime is the four-dimensional fabric that combines the three dimensions of space with the dimension of time. It's not a static stage, but a dynamic, flexible medium that can be warped and bent by massive objects like stars and black holes. Light, traveling through this fabric, follows these curves, creating the phenomena we observe, from gravitational lensing to the bending of starlight. But light's speed, the fastest anything can travel in the universe, also defines the limits of our perception. Because light takes time to travel, we're always seeing the universe as it was, not as it is. This delay creates a cosmic clock, ticking at the speed of light. One of the most fascinating consequences of this interplay between light and spacetime is time dilation, a phenomenon predicted by Einstein's theory of relativity. Time dilation occurs when time passes differently for observers in different gravitational fields or moving at different speeds. For example, a clock near a massive object like a black hole will tick more slowly than one far away. Similarly, an astronaut traveling close to the speed of light will experience time passing more slowly than someone on Earth. These effects, though subtle in our everyday lives, become profound in the extreme environments of the cosmos. They remind us that time is not absolute but relative, shaped by the forces of gravity and motion. But light doesn't just reveal the present and the past, it also carries echoes of the universe's infancy. The cosmic microwave background, a faint glow of light that permeates the universe, is the oldest light we can observe. It's a snapshot of the universe just 380,000 years after the Big Bang, a time when the cosmos was a hot, dense soup of particles and energy. As the universe expanded and cooled, this light was released, traveling through space for over 13 billion years to reach us. Today, it serves as a time capsule, preserving the conditions of the early universe and offering clues about its origins and evolution. The cosmic microwave background isn't just a relic of the past, it's also a map of the universe's structure. Tiny variations in its temperature and intensity reveal the seeds of galaxies and clusters, the first hints of the cosmic web that would later form. These variations are like fingerprints, encoding the universe's history in light. By studying them, astronomers can piece together the story of how the universe grew from a hot, uniform state to the complex, diverse cosmos we see today. As we explore the relationship between light, shadow, and time, we begin to see how these forces are intertwined in the universe's grand design. Light defines our perception of time, while spacetime shapes the paths light can take. Shadows, too, play a role, revealing the presence of objects that warp spacetime and alter the flow of time. Together, they create a dynamic interplay that governs the cosmos, from the smallest particles to the largest structures. But what does this mean for our search for life beyond Earth? Could the interplay of light and shadow hold clues to finding extraterrestrial worlds? As we turn our gaze to the stars, we'll explore how these cosmic forces might guide us in the quest to discover life elsewhere in the universe. What secrets might light and shadow reveal about the potential for life on distant planets? The answers lie in the delicate balance of these forces, a balance that shapes not just the cosmos, but our place within it. The search for life beyond Earth is one of humanity's most profound quests, and it's a journey that relies heavily on the interplay of light and shadow. These forces, which shape the universe on every scale, also hold the key to unlocking the mysteries of alien worlds, from the faint flicker of a distant star to the subtle shadows cast by orbiting moons. Light and shadow are the tools that guide us in our search for extraterrestrial life. One of the most powerful ways we detect potential life on other planets is through light, specifically the light that passes through a planet's atmosphere. When an exoplanet transits or passes in front of its star, it casts a shadow that we can observe from Earth. But this shadow is more than just a dip in brightness. It's a treasure trove of information. As starlight filters through the planet's atmosphere, certain wavelengths are absorbed by gases like oxygen, methane, or carbon dioxide. These absorption patterns, known as biosignatures, can reveal the chemical makeup of the atmosphere and hint at the presence of life. For example, the detection of oxygen alongside methane could suggest biological activity, as these gases are often produced by living organisms. In this way, light becomes a cosmic detective, uncovering clues about the habitability of distant worlds. Shadows, too, play a vital role in the search for life. Take, for instance, the shadows cast by moons orbiting gas giants. These moons, like Jupiter's Europa or Saturn's Enceladus, are often hidden beneath thick layers of ice. But the gravitational tug of their parent planets creates tidal forces that generate heat, potentially melting the ice and creating subsurface oceans. The shadows cast by these moons aren't just aesthetic, they're indicators of environments where life might thrive. In the cold, dark depths of these oceans, shielded from the harsh radiation of space, microbial life could exist, a possibility that excites scientists and fuels missions to explore these icy worlds. Light and shadow also help us identify habitable zones, the regions around a star where conditions might be just right for liquid water to exist. Too close to a star, and a planet's water would evaporate under intense heat. Too far, and it would freeze in perpetual shadow. The balance between light and shadow defines these zones, making them the prime targets in our search for life. For example, the TRAPPIST-1 system, with its 7 Earth-sized planets, has 3 worlds orbiting within the habitable zone. The interplay of light and shadow on these planets could determine whether they have the right conditions to support life as we know it. But the search for life isn't just about finding the right conditions, it's about understanding the stories that light and shadow tell. Every flicker of a star, every shadow cast by a distant world, is a piece of a cosmic puzzle. By studying these signals, we're not just looking for life, we're uncovering the broader narrative of how planets form, evolve, and potentially sustain living organisms. It's a story written in the language of light and shadow, one that continues to inspire and challenge us. As we gaze at the stars and ponder the possibilities, we're reminded that the search for life is as much about imagination as it is about science. Light and shadow not only guide our exploration, but also spark our curiosity, inviting us to dream of worlds beyond our own. And as we continue to explore, we'll find that these forces are more than just tools, they're the threads that connect us to the cosmos. In the next chapter of our journey, we'll step beyond the realm of science and into the world of art and culture. where light and shadow have inspired humanity for millennia. From ancient myths to modern masterpieces, these forces have shaped our understanding of the universe and our place within it. What stories do they tell, and how do they reflect our deepest hopes and fears? The answers await, where science and creativity meet in the dance of light and shadow. Throughout history, light and shadow have not only shaped the cosmos, but also the human imagination, inspiring some of the most profound expressions of art and culture. From the ethereal glow of auroras dancing across polar skies to the dramatic silhouettes of solar eclipses, these celestial phenomena have captivated our senses and stirred our creativity. They remind us that the universe is not just a scientific wonder, but also a boundless source of beauty, inviting us to see the cosmos through the eyes of artists, poets, and dreamers. Consider the auroras, those shimmering curtains of light that paint the night sky in hues of green, purple, and red. These luminous displays, caused by charged particles from the sun interacting with Earth's magnetic field, are more than just a scientific marvel. They are a canvas for the human spirit. For centuries, they have been woven into myths and legends, from the Norse belief that the auroras were the reflections of warriors' shields to the Inuit stories of spirits playing ball with a walrus skull. Today, they continue to inspire photographers, painters, and writers who seek to capture their fleeting beauty and translate it into something timeless. Eclipses, too, have left an indelible mark on human culture. A solar eclipse, with its sudden plunge into darkness and the awe-inspiring corona of the sun revealed, has been a source of both fear and fascination. Ancient civilizations often saw eclipses as omens, while modern societies celebrate them as opportunities to witness the grandeur of the cosmos. Artists have immortalized these events in paintings and poetry, capturing the interplay of light and shadow that defines them. It's a reminder that even in the darkest moments, there is a glimmer of brilliance, a cosmic balance that resonates deeply with the human experience. The starry night sky, perhaps the most universal muse, has inspired countless works of art and literature. Vincent van Gogh's iconic painting, Starry Night, is a testament to the power of the cosmos to evoke emotion and wonder. The swirling patterns of stars and the luminous crescent moon are not just a depiction of the night sky, but a reflection of the artist's inner world, a merging of the celestial and the personal. Similarly, writers like Carl Sagan and Mary Oliver have used the stars as metaphors for hope, mystery, and the infinite possibilities of existence. The night sky, with its interplay of light and shadow, becomes a mirror for our own dreams and aspirations. Music, too, has been shaped by the echoes of the cosmos. Composers like Gustav Holst, in his orchestral suite The Planets, have translated the majesty of the solar system into sound, using melodies and harmonies to evoke the character of each celestial body. Modern musicians, from classical to electronic genres, continue to draw inspiration from the cosmos, creating soundscapes that transport listeners to distant galaxies and nebulae. These compositions are more than just auditory experiences. They are a way of connecting with the universe on an emotional level, a reminder that the cosmos speaks not just to our minds, but to our hearts. But the influence of light and shadow extends beyond individual works of art. It has shaped entire movements and philosophies. The Romantic era, for example, was deeply influenced by the sublime beauty of nature and the cosmos. Artists and thinkers of the time saw the universe as a source of inspiration and transcendence, a way to connect with something greater than themselves. This legacy continues today as we grapple with questions about our place in the universe and the meaning of existence. The interplay of light and shadow, both literal and metaphorical, becomes a way of exploring these profound questions, a lens through which we can examine the mysteries of life and the cosmos. As we reflect on the artistic and cultural impact of light and shadow, we're reminded that the cosmos is not just a scientific frontier, but a wellspring of creativity and wonder. It invites us to look beyond the facts and figures, to see the universe as a source of beauty, inspiration, and meaning. And as we continue to explore the philosophical implications of these forces, we'll discover how they shape not just our understanding of the cosmos, but our understanding of ourselves. What deeper truths do light and shadow hold about the nature of existence, and how do they guide us in our search for meaning? These are the questions that await us as we delve into the philosophical dimensions of the cosmic dance. Light and shadow are more than just physical phenomena, they are profound metaphors for the dual nature of existence itself. Across cultures and throughout history, these forces have symbolized the eternal dance between opposites, knowledge and ignorance, creation and destruction, life and death. They remind us that the universe is not a place of absolutes but of balance, where every light casts a shadow, and every shadow hides the potential for light. This duality is not just a scientific truth, but a philosophical one, offering insights into the nature of reality and our place within it. In ancient mythology, light and shadow often represented the struggle between order and chaos. The Egyptian god Ra, the sun deity, was seen as the bringer of light and life, while his nightly journey through the underworld symbolized the constant battle against darkness and death. Similarly, in Greek mythology, Apollo, the god of light, stood in contrast to Hades, the ruler of the shadowy underworld. These stories reflect a universal understanding that light and shadow are inseparable, each giving meaning to the other. Without darkness, light would lose its brilliance. Without light, darkness would have no form. Philosophy, too, has long grappled with the symbolism of light and shadow. Plato's famous allegory of the cave describes prisoners chained in darkness, mistaking shadows on a wall for reality. When one prisoner escapes and sees the light of the sun, he realizes the truth, a metaphor for enlightenment and the pursuit of knowledge. Here, light represents understanding, while shadow symbolizes ignorance. Yet, even in this story, the interplay between the two is essential. The prisoner's journey from darkness to light is not just about escaping ignorance, but about understanding the relationship between the two. It's a reminder that knowledge often emerges from the shadows of uncertainty. This duality extends to the very fabric of the universe. In physics, light and shadow are not just opposites but complementary forces. Quantum mechanics, for example, reveals that particles can exist in states of superposition, both here and there, both light and shadow, until observed. This principle, known as wave-particle duality, challenges our classical notions of reality, suggesting that the universe is far more fluid and interconnected than we once thought. Light and shadow, in this sense, become metaphors for the paradoxes that define existence, where opposites coexist and even depend on each other. But what does this mean for us as individuals? On a personal level, light and shadow can represent the complexities of human experience. Moments of joy are often followed by times of sorrow. Periods of clarity can give way to confusion. This ebb and flow is not something to resist but to embrace, as it shapes the richness of our lives. Just as a painting needs both light and shadow to achieve depth, our experiences gain meaning from their contrasts. It's a reminder that growth often comes from navigating the shadows, finding light in unexpected places, and learning to see the beauty in both. As we reflect on the philosophical significance of light and shadow, we're reminded that they are not just forces to be observed, but lessons to be lived. They teach us about balance, resilience, and the interconnectedness of all things, and as we look to the future, we're left with a tantalizing question. How will these forces continue to shape the universe and our understanding of it? In the next chapter of our journey, we'll explore the evolving role of light and shadow in the cosmos, from the birth of new stars to the mysteries of dark energy. What secrets will they reveal, and how will they guide us in our quest to understand the universe's ultimate fate? The answers lie in the ever-changing dance of light and shadow, a partnership that continues to illuminate the path forward. As we gaze into the vast expanse of the cosmos, it's impossible not to wonder about the future, not just our own, but the future of the universe itself. What role will light and shadow play as the cosmos continues to evolve? The story of the universe is far from over, and these forces will remain at the heart of its unfolding narrative, shaping everything from the fate of stars to the ultimate destiny of spacetime. One of the most intriguing possibilities is the concept of the heat death of the universe. In this scenario, the cosmos continues to expand, driven by dark energy until stars burn out, galaxies drift apart, and the universe becomes a cold, dark void. Over trillions of years, the last remnants of light will fade, leaving only the faint echoes of what once was. It's a sobering thought, a universe where shadow reigns supreme and the brilliant light of stars is but a memory. Yet, even in this distant future, the echoes of light and shadow will persist, carrying the story of the universe's vibrant past into the endless expanse of time. But what if the universe has more surprises in store? Some theories suggest that the cosmos might not end in darkness, but could instead undergo a transformation, giving rise to new cycles of creation. Imagine a scenario where the universe contracts, collapsing back into a dense state before exploding once again in a new Big Bang. In this cyclical model, light and shadow would play their roles anew, shaping the birth of new stars, galaxies, and perhaps even life. The echoes of the previous universe might linger, influencing the structure and evolution of the next, creating a cosmic dance that repeats across eternity. These interstellar echoes, whether they are the remnants of ancient supernovae, the whispers of long-dead stars, or the gravitational ripples of black holes, are more than just relics of the past. They are also windows into the future, offering clues about how the universe might evolve. By studying these echoes, we can piece together the story of cosmic evolution, from the fiery birth of the first stars to the quiet fading of the last. They remind us that the universe is not static but dynamic, a place of constant change and renewal. Yet, as we ponder these grand cosmic scenarios, it's worth reflecting on humanity's place in this vast tapestry. We are but fleeting observers in a universe that spans billions of years, yet our curiosity and ingenuity allow us to glimpse its deepest mysteries. The light we see today, the shadows we study, and the echoes we detect are not just scientific phenomena, they are reminders of our connection to the cosmos. They invite us to dream, to explore, and to imagine what lies beyond the horizon of our understanding. As we continue our journey, we'll turn our attention to the tools and technologies that allow us to explore these cosmic mysteries, from cutting-edge telescopes to innovative space missions. How do we capture and interpret the light and shadow of the universe, and what discoveries await us as we push the boundaries of exploration? The answers lie in the interplay of science, technology, and imagination, a partnership that continues to illuminate the path forward. As we stand beneath the vast canopy of stars, gazing into the infinite expanse of the cosmos, it's worth pausing to reflect on our unique role in this grand cosmic dance. Humanity, for all its fleeting existence, has become a witness to the universe's most profound interplay of light and shadow. Through telescopes, space probes, and the power of imagination, we've unlocked secrets that stretch across billions of years and trillions of miles. But what does it mean to be an observer in a universe so vast, so ancient, and yet so intricately connected to our own existence? Our journey to understand the universe began with simple observations, tracking the movements of the sun, moon, and stars. Over centuries, these observations evolved into a deeper quest, driven by curiosity and the desire to uncover the forces shaping the cosmos. The discovery of the cosmic microwave background, the mapping of distant galaxies, and the groundbreaking image of a black hole's shadow are all milestones in our collective effort to decode the language of light and shadow. These interstellar echoes, as we've come to call them, are not just scientific discoveries. They are stories etched into the fabric of the universe, waiting for us to listen and learn. What makes humanity's role so remarkable is not just our ability to observe, but our capacity to interpret. We've transformed raw data into meaningful narratives, turning faint signals from distant stars into insights about the birth of galaxies, the life cycles of stars, and the mysterious forces of dark matter and dark energy. Each discovery is a testament to our ingenuity and determination, a reminder that even in a universe so vast, we have the power to uncover its secrets. But our role as witnesses goes beyond science. It's also about connection. When we look up at the night sky, we're not just seeing points of light, we're glimpsing the shared history of everything that exists. The light from a distant star may have traveled for millions of years to reach us, carrying with it echoes of a time before humanity even existed. In that light, we find a profound sense of unity, a reminder that we are part of something much larger than ourselves. This understanding of our place in the cosmos has profound implications for our future. As we continue to explore, we're not just expanding our knowledge, we're also shaping the way we think about our responsibilities as stewards of Earth and explorers of the universe. The more we learn about the delicate balance of light and shadow, the more we realize how interconnected everything is, from the smallest particles to the largest galaxies. This awareness can inspire us to approach challenges with humility and curiosity, knowing that the universe is full of mysteries waiting to be uncovered. Yet, for all we've learned, the cosmos remains a place of wonder and awe. Every new discovery brings with it more questions, more opportunities to explore. The echoes of light and shadow remind us that the universe is not just a static backdrop, but a dynamic, ever-changing stage. And as long as we continue to look up and ask questions, we'll remain active participants in this cosmic dance, uncovering new truths and forging new connections. But our exploration of the universe isn't just about science and discovery, it's also about emotion. The interplay of light and shadow has always stirred something deep within us, evoking feelings of wonder, curiosity, and even humility. In the next part of our journey, we'll explore how these forces resonate on a personal level, shaping our art, our stories, and our sense of place in the cosmos. What does it mean to stand beneath a starry sky, to witness an eclipse, or to gaze at the swirling colors of a nebula? These are the questions that connect us not just to the universe, but to each other. And as we delve into the emotional impact of light and shadow, we'll discover how the cosmos speaks not just to our minds, but to our hearts. There's something profoundly humbling about standing beneath a starry sky, where the interplay of light and shadow stretches endlessly above us. It's a moment that transcends science, touching something deep within our souls. The cosmos, with its swirling galaxies, glowing nebulae, and silent darkness, evokes emotions that are as vast and complex as the universe itself. Awe, wonder, and humility, these are the feelings that arise when we contemplate the sheer scale and beauty of the cosmos. It's not just about what we see, it's about how it makes us feel, how it connects us to something greater than ourselves. Astronauts often speak of this emotional impact when they look down at Earth from space, a phenomenon known as the overview effect. Seeing our planet as a fragile blue marble against the infinite blackness of space, they describe an overwhelming sense of unity and perspective. The Earth is the only thing we've ever known that's alive, astronaut Ron Garan once reflected, and it's so fragile and so beautiful. This interplay of light, the vibrant blues and greens of Earth, and shadow, the vast void of space creates a profound emotional response, one that shifts their understanding of humanity's place in the universe. It's a reminder that, in the grand scheme of things, we are both insignificant and extraordinary, tiny yet deeply connected to the cosmos, but you don't need to travel to space to feel this awe. A simple glance at a starry night, a solar eclipse, or even the shimmering colors of the aurora can evoke a similar sense of wonder. These moments remind us that the universe is not just a collection of objects to study, but a source of inspiration and reflection. The light from a distant star, traveling millions of years to reach us, carries with it a story of cosmic creation. The shadow of a planet passing in front of its sun hints at the vastness of possibilities beyond our own world. These experiences, whether grand or subtle, invite us to pause and marvel at the mysteries of existence. Yet, for all the beauty and emotion these phenomena inspire, they also present immense scientific challenges. Capturing and interpreting the light and shadow of the universe requires cutting-edge technology and relentless curiosity. From building telescopes that can peer into the farthest reaches of space to developing instruments that can detect the faintest whispers of cosmic echoes, scientists are constantly pushing the boundaries of what we can observe and understand. The interplay of light and shadow is not just a source of wonder, it's a puzzle, a code waiting to be deciphered. And as we continue to unravel its secrets, we're reminded that the cosmos is both a mirror and a mystery, reflecting our emotions even as it challenges our understanding. What drives us to keep exploring, to keep seeking answers in the light and shadow of the universe? Perhaps it's the same sense of awe and wonder that first drew humanity to look up at the stars. It's a reminder that science and emotion are not separate but deeply intertwined, each enriching the other in our quest to understand the cosmos. And as we turn our gaze to the scientific challenges ahead, we'll discover how these forces continue to shape not just our understanding of the universe, but our connection to it. The mysteries of light and shadow in the cosmos are as vast as the universe itself, and unraveling them presents some of the most formidable challenges in modern science. While we've made incredible strides in understanding these forces, the sheer scale and complexity of the cosmos often push the boundaries of what our technology and theoretical frameworks can achieve. From capturing the faintest glimmers of distant stars to mapping the invisible influence of dark matter, each discovery is a testament to human ingenuity and a reminder of how much we still have to learn. One of the biggest challenges lies in the limitations of our current technology. Even the most advanced telescopes, like the James Webb Space Telescope, can only capture a fraction of the light that reaches us. Infrared and radio telescopes help us peer through cosmic dust and gas, but much of the universe remains hidden in wavelengths we can't yet detect. For example, gravitational waves, ripples in spacetime caused by violent cosmic events, are incredibly faint and require highly sensitive instruments like LIGO to observe. These tools are engineering marvels, but they're just the beginning. To truly uncover the secrets of light and shadow, we need even more precise and innovative instruments, capable of detecting signals that are currently beyond our reach. Theoretical challenges are equally daunting. Take black holes, for instance. These enigmatic objects warp light and shadow in ways that defy our understanding of physics. While Einstein's theory of general relativity provides a framework for understanding their behavior, it breaks down at the event horizon, where the laws of physics, as we know them, cease to apply. Unifying relativity with quantum mechanics, the other pillar of modern physics, remains one of the greatest unsolved problems in science. It's a puzzle that requires not just new technology, but entirely new ways of thinking, a paradigm shift that could redefine our understanding of the universe. Despite these challenges, scientists are making remarkable progress. Ongoing missions like the Vera-C, Rubin Observatory, and the Nancy Grace Roman Space Telescope are set to revolutionize our view of the cosmos. These projects will map the sky in unprecedented detail, capturing the faintest echoes of light and shadow from distant galaxies and cosmic events. Meanwhile, initiatives like the Event Horizon Telescope continue to push the boundaries of what we can observe, bringing us closer to understanding the nature of black holes and the extreme conditions they create. Each mission is a step forward in our quest to decode the universe's most profound mysteries. But the pursuit of knowledge isn't just about building better tools or refining theories, it's about collaboration. The challenges we face are too vast for any one person, team, or even country to tackle alone. It takes a global effort, with scientists from diverse disciplines working together to piece together the puzzle of the cosmos. In the next part of our journey, we'll explore how collaboration drives cosmic research, uniting minds across borders and disciplines to uncover the secrets of light and shadow. What role does teamwork play in our exploration of the universe, and how does it shape the future of discovery? The answers lie in the power of collective effort, a force as vital to science as the light and shadow we seek to understand. The quest to unravel the mysteries of light and shadow in the universe is not a journey undertaken by any one nation or individual. It's a global endeavor. Across continents, scientists, engineers, and researchers unite under a shared mission to decode the secrets of the cosmos. This international collaboration has become the cornerstone of modern astronomy, enabling breakthroughs that would be impossible in isolation. From the vast deserts of Chile to the frozen plains of Antarctica, observatories and research facilities work in harmony, pooling their expertise and resources to push the boundaries of what we know. Organizations like NASA, the European Space Agency, ESA, and others play a pivotal role in this collective effort. Take, for example, the Hubble Space Telescope, a collaboration between NASA and ESA that has revolutionized our understanding of the universe. By capturing stunning images of distant galaxies, nebulae, and black holes, Hubble has provided a window into the interplay of light and shadow on a cosmic scale. Similarly, the James Webb Space Telescope, a joint project involving NASA, ESA, and the Canadian Space Agency, is now peering deeper into space than ever before, revealing the faintest echoes of light from the earliest moments of the universe. These missions are not just feats of engineering, they are testaments to what humanity can achieve when we work together. But collaboration isn't limited to space agencies. Ground-based observatories, like the Atacama Large Millimeter Array, ALMA, in Chile, bring together scientists from dozens of countries to study the universe in unprecedented detail. ALMA's ability to observe the faint radio waves emitted by distant stars and galaxies has shed light on the formation of planetary systems and the birth of stars. By sharing data and resources, these international teams are able to tackle questions that transcend borders, from the nature of dark matter to the origins of cosmic light. The importance of collaboration extends beyond professional scientists. Open data policies, where research findings and observations are shared freely, have become a hallmark of modern astronomy. This transparency not only accelerates discovery, but also fosters a sense of global unity, as researchers from diverse backgrounds contribute their unique perspectives to solving cosmic puzzles. Whether it's mapping the distribution of dark matter or studying the gravitational lensing of light around massive objects, the combined efforts of the global scientific community are reshaping our understanding of the universe. Yet, the story of cosmic exploration doesn't end with professional scientists. Citizen scientists, enthusiastic individuals from all walks of life, are playing an increasingly vital role in this global effort. Projects like Zooniverse invite the public to analyze astronomical data, from classifying distant galaxies to identifying potential exoplanets. These contributions, though small in isolation, add up to a powerful force, enabling discoveries that might otherwise go unnoticed. Citizen science not only democratizes research, but also nurtures a deeper connection between humanity and the cosmos, reminding us that the universe belongs to everyone. This spirit of collaboration, from the highest levels of academia to the living rooms of curious individuals, is what drives cosmic research forward. It's a reminder that the mysteries of light and shadow are not just scientific challenges, but shared human experiences. As we continue to explore the universe together, we're not just uncovering its secrets, we're building bridges between cultures, disciplines, and generations. And in this collective effort, we find not only answers but also a deeper understanding of our place in the cosmos. As we turn our attention to the role of citizen science, we'll see how everyday people are contributing to the exploration of the universe, transforming curiosity into discovery and proving that the cosmos is within everyone's reach. What role might you play in this grand endeavor? The answer lies in the power of participation, where even the smallest contribution can illuminate the vast mysteries of the universe. The universe is vast, but its exploration isn't reserved solely for professional scientists in white lab coats. In fact, some of the most exciting discoveries in astronomy have come from everyday people, teachers, students, artists, and enthusiasts who have dedicated their time and curiosity to the cosmos. This is the world of citizen science, where the study of light and shadow in the universe becomes a shared human endeavor, open to anyone with an internet connection and a sense of wonder. Projects like Galaxy Zoo and the search for exoplanets have turned the public into active participants in cosmic discovery, proving that you don't need a PhD to contribute to our understanding of the universe. Galaxy Zoo, one of the most well-known citizen science initiatives, invites volunteers to classify galaxies based on images taken by telescopes. With millions of galaxies to analyze, even the most advanced computers struggle to identify subtle patterns and features. That's where the human eye comes in, by simply logging on and categorizing galaxies as spiral, elliptical, or irregular. Participants help astronomers map the structure of the universe. These classifications reveal how galaxies form and evolve, offering clues about the interplay of light, shadow, and gravity on cosmic scales. What's remarkable is that many of these volunteers have no formal training in astronomy, just a passion for discovery and a willingness to learn. Another groundbreaking project, Planet Hunters, enlists the public in the search for exoplanets' worlds orbiting distant stars. Volunteers sift through data from NASA Kepler and TESS missions, looking for tiny dips in a star's brightness that might indicate a planet passing in front of it. These dips, often no more than a faint flicker, are easy for algorithms to miss but can be spotted by the keen eyes of dedicated participants. Thanks to their efforts, dozens of exoplanets have been discovered, including some that could potentially support life. It's a reminder that the shadows cast by distant worlds hold secrets waiting to be uncovered, and that anyone can play a part in finding them. What makes citizen science so powerful is its ability to democratize discovery. By breaking down barriers and inviting everyone to contribute, these projects transform the study of the cosmos from an exclusive pursuit into a collective adventure. They remind us that the universe belongs to all of us, and that its mysteries are not just for scientists to solve, but for humanity to explore together. This inclusivity has not only accelerated research, but also fostered a deeper connection between people and the cosmos. For many participants, the act of classifying a galaxy or spotting an exoplanet becomes more than just a task. It's a moment of awe, a chance to feel connected to something larger than themselves. The impact of citizen science extends far beyond individual discoveries. By engaging the public in cosmic exploration, these projects inspire curiosity, spark interest in STEM fields, and cultivate a sense of shared responsibility for our collective knowledge. They also highlight the importance of collaboration in science, showing that the most profound insights often come from diverse perspectives working together. Whether it's uncovering the structure of distant galaxies or identifying the faint shadows of exoplanets, citizen scientists are helping to write the story of the universe, one observation at a time. But as we celebrate the democratization of science, it's worth pausing to consider the broader implications of our cosmic explorations. What responsibilities come with unraveling the mysteries of the universe? How do we ensure that our pursuit of knowledge is ethical and inclusive? These questions lead us to the next chapter of our journey, where we'll explore the ethical dimensions of cosmic discovery, a topic as vast and complex as the cosmos itself. What principles should guide our exploration, and how can we navigate the challenges that arise as we reach further into the unknown? The answers lie in the delicate balance between curiosity and responsibility, a balance that defines not just our relationship with the universe, but with each other. As we venture deeper into the cosmos, uncovering the secrets of light and shadow, we must also confront the ethical challenges that come with exploration. The pursuit of knowledge is a noble endeavor, but it carries with it a profound responsibility to protect not only our own planet, but also the pristine environments we seek to study. Space, once thought to be an infinite and untouchable frontier, is now a shared resource, and our actions within it have consequences that ripple far beyond Earth. From the growing problem of space debris to the risks of contaminating other worlds, the ethical considerations of cosmic exploration are as vast and complex as the universe itself. One of the most pressing ethical issues is the proliferation of space debris. Thousands of defunct satellites, spent rocket stages, and fragments from collisions now orbit Earth, creating a hazardous environment for both current and future missions. This debris, traveling at incredible speeds, poses a threat to active satellites, the International Space Station, and even crewed missions. The challenge is not just technical but ethical. How do we balance the benefits of space exploration with the need to preserve a safe and sustainable orbital environment? Initiatives like active debris removal and stricter regulations on satellite deployment are steps in the right direction, but they require global cooperation and a shared commitment to responsible stewardship. Another critical concern is planetary protection, the effort to prevent contamination of other worlds with Earth-based organisms. As we send probes to Mars, Europa, and beyond, we must ensure that we don't inadvertently introduce microbes that could disrupt potential extraterrestrial ecosystems or compromise scientific investigations. The principle of planetary protection is rooted in respect for the integrity of other worlds and respect for our own role as explorers. It's a reminder that our curiosity must be tempered by caution, and that the search for life elsewhere begins with safeguarding the environments we study. Equally important is the ethical responsibility of sharing discoveries. The knowledge we gain from studying light and shadow in the universe is a collective heritage, one that belongs to all of humanity. Yet, access to this knowledge is often uneven, with some nations and communities having greater resources and opportunities than others. Bridging this gap requires not only open data policies, but also a commitment to inclusivity, ensuring that the benefits of cosmic exploration are shared equitably. Programs like the United Nations Office for Outer Space Affairs aim to promote international collaboration and capacity building, fostering a sense of global partnership in our quest to understand the cosmos. These ethical considerations are not just abstract principles, they are practical guidelines that shape the future of exploration. They remind us that the pursuit of knowledge is not an end in itself, but a means to enrich our understanding of the universe and our place within it. As we grapple with these questions, we're also reminded of the cultural significance of light and shadow, not just as scientific phenomena, but as symbols that resonate across time and cultures. From ancient myths to modern art, these forces have inspired humanity to dream, to create, and to explore, connecting us to the cosmos in profound and enduring ways. In the next chapter of our journey, we'll delve into the cultural and artistic legacy of light and shadow, exploring how these forces have shaped human imagination and creativity. What stories do they tell, and how do they reflect our deepest hopes and fears? The answers lie in the intersection of science and art, where the cosmos becomes not just a subject of study, but a source of inspiration and wonder. From the flickering flames of ancient campfires to the dazzling glow of modern cities, light and shadow have been integral to the human experience. They are more than just physical phenomena, they are cultural touchstones, woven into the fabric of our history, religion, and daily lives. Across civilizations, these forces have inspired awe, shaped rituals, and sparked the imagination, leaving an indelible mark on how we see the world and our place within it. The interplay of light and shadow is not just a cosmic dance, it's a mirror reflecting humanity's deepest hopes, fears, and aspirations. In many ancient cultures, light was synonymous with life, knowledge, and divinity. The Egyptians revered Ra, the sun god, whose daily journey across the sky symbolized the eternal cycle of life and death. For the Greeks, Apollo, the god of light, represented reason, art, and healing, standing in stark contrast to the shadowy realms of Hades. These mythologies reveal a universal truth. Light and shadow are not just opposites but complementary forces, each giving meaning to the other. Without darkness, light would lose its brilliance. Without light, shadow would have no form. This duality has shaped the way we understand the world, from the sacred to the mundane. Light has also played a central role in religious practices and rituals. In Christianity, light is a symbol of divine presence and salvation, often represented by candles, stained glass, and the metaphor of Christ as the light of the world. In Hinduism, the festival of Diwali celebrates the triumph of light over darkness, with millions of oil lamps illuminating homes and temples. Similarly, in Buddhism, light is a metaphor for enlightenment, the path to transcending suffering and ignorance. These traditions remind us that light and shadow are not just physical phenomena, but spiritual concepts, guiding us toward deeper understanding and connection. But the influence of light and shadow extends beyond religion and mythology. In daily life, they shape our rhythms and routines, from the rising and setting of the sun to the soft glow of a moonlit night. Before the advent of electricity, the cycles of light and darkness dictated when people worked, rested, and celebrated. Even today, the interplay of light and shadow continues to inspire art, architecture, and design. Think of the way sunlight filters through the stained glass of a cathedral, casting vibrant patterns on stone floors, or how the stark contrast of chiaroscuro in Renaissance paintings brings depth and drama to human figures. These artistic expressions are a testament to the enduring power of light and shadow to captivate and move us. The concept of interstellar echoes takes this cultural significance to a cosmic scale. Just as ancient civilizations looked to the heavens for guidance and inspiration, we now turn to the stars, seeking answers to questions about our origins and destiny. The light from distant galaxies, the shadows cast by black holes, and the echoes of ancient supernova are not just scientific phenomena, they are stories waiting to be told. They remind us that the universe is not just a place of facts and figures, but a source of wonder and meaning, connecting us to something greater than ourselves. As we reflect on the cultural significance of light and shadow, it's impossible not to marvel at how these forces continue to inspire and challenge us. They are more than just themes in art and religion, they are metaphors for the human condition, representing the balance between knowledge and ignorance, hope and despair, creation and destruction. And as we turn our gaze to the next chapter of our journey, we'll explore how light and shadow shape one of humanity's most enduring traditions, storytelling. What role do these forces play in the tales we tell, and how do they help us make sense of the world? The answers lie in the power of narrative, where light and shadow become not just elements of the cosmos, but threads in the tapestry of our shared imagination. Throughout human history, light and shadow have served as powerful tools for storytelling, weaving tales that transcend time and culture. These forces, so fundamental to our existence, have shaped myths and legends, offering explanations for the mysteries of the cosmos and reflecting humanity's deep connection to the heavens. From the sun gods of ancient civilizations to the moonlit spirits of folklore, the interplay of light and shadow has inspired stories that are as diverse as they are universal, revealing our shared fascination with the universe and our place within it. One of the most enduring themes in these stories is the sun, a symbol of life, power, and renewal. In ancient Egypt, the sun god Ra sailed across the sky each day, bringing light to the world and warding off the forces of darkness. His journey mirrored the cycle of day and night, a reminder of the balance between light and shadow that governs life on Earth. Similarly, in Aztec mythology, the sun was seen as a source of vitality, with the god Huitzilopochtli requiring constant nourishment through human sacrifice to ensure its daily rise. These myths illustrate how the sun, in its brilliance, became a central figure in humanity's attempts to understand the rhythms of nature and the cosmos. The moon, too, has captured the human imagination, often portrayed as a gentle counterpart to the sun's fiery intensity. In Greek mythology, the moon goddess Selene rode her silver chariot across the night sky, casting soft light over the earth and guiding souls through the darkness. In contrast, many Native American traditions depict the moon as a trickster or a keeper of secrets, its phases symbolizing the ebb and flow of life's mysteries. These stories remind us that the moon, with its ever-changing face, embodies the duality of light and shadow, offering both comfort and intrigue. Stars, those distant points of light scattered across the night sky, have also played a central role in storytelling. For the Maori of New Zealand, the Pleiades star cluster, known as Matariki, marked the beginning of the new year and was celebrated as a time of renewal and remembrance. In Greek mythology, the stars were often seen as the souls of heroes or as divine beings placed in the sky to guide and inspire. These celestial narratives reveal how humanity has looked to the stars not just for navigation or timekeeping, but for meaning and connection, seeing in their light a reflection of our own hopes and dreams. What makes these myths so compelling is their ability to use light and shadow as metaphors for the human experience. Light often symbolizes knowledge, hope, and life, while shadow represents the unknown, fear, and the passage of time. Together, they create a rich tapestry of meaning, allowing storytellers to explore themes of creation, transformation, and the eternal struggle between order and chaos. These stories, passed down through generations, remind us that the cosmos is not just a place of physical phenomena, but a source of inspiration and wonder, shaping the way we see ourselves and the world around us. As we transition from ancient myths to modern media, we see that the power of light and shadow in storytelling has only grown stronger. Today, filmmakers, writers, and artists continue to draw on these timeless themes, using light and shadow to evoke emotion, create atmosphere, and explore the complexities of the human condition. From the haunting chiaroscuro of classic cinema to the dazzling special effects of modern sci-fi, light and shadow remain essential tools for bringing stories to life, connecting us to the cosmos in ways that are both profound and deeply personal. In the next chapter of our journey, we'll delve into how these forces shape the stories we tell today, bridging the gap between ancient myths and contemporary creativity. In modern media, light and shadow are no longer just visual elements, they are powerful tools for storytelling, world building, and creating immersive experiences. From the silver screen to the digital realms of video games and virtual reality, these forces are harnessed to evoke emotion, heighten tension, and transport audiences to distant galaxies. The interplay of light and shadow isn't just about aesthetics, it's about crafting environments that feel alive, dynamic, and deeply connected to the cosmos. Through these mediums, we don't just observe the universe, we experience it. Take, for example, the world of cinema. Films like Interstellar and Gravity use light and shadow to create a sense of awe and vulnerability in the vastness of space. In Interstellar, the eerie glow of a black hole's accretion disk contrasts with the pitch-black void, emphasizing the fragility of human life against the backdrop of cosmic forces. Similarly, Gravity uses the stark interplay of sunlight and darkness to heighten the isolation of space, with the Earth's radiant glow serving as a haunting reminder of home. These films don't just depict space, they make us feel it, using light and shadow to evoke wonder, fear, and introspection. Video games, too, have embraced the power of light and shadow to create immersive cosmic experiences. Titles like No Man's Sky and Elite Dangerous allow players to explore procedurally generated galaxies, where the glow of distant stars and the shadows of alien worlds create a sense of endless possibility. In Mass Effect, the interplay of light and shadow is used to convey the mood of alien civilizations, from the neon-lit streets of futuristic cities to the dimly lit corridors of derelict spaceships. These games aren't just entertainment, they're interactive journeys that invite players to ponder the mysteries of the universe, one pixel at a time. Virtual reality takes this immersion to another level. With VR, the cosmos becomes a space you can step into, where the light from a star feels close enough to touch, and the shadows of distant planets stretch across your field of vision. Experiences like Titans of Space and Cosmic Sugar VR let users explore the scale and beauty of the universe in ways that were once the realm of science fiction. These tools don't just show us the cosmos, they make us feel like a part of it, blurring the line between observer and participant. But beyond their entertainment value, these media representations shape how we understand and connect with the concept of interstellar echoes. By depicting the universe as a place of light and shadow, they remind us of the delicate balance that defines existence. They show us that the cosmos is not just a backdrop, but a living, breathing entity, full of stories waiting to be discovered. And as we engage with these stories, we begin to see ourselves not just as passive viewers, but as active participants in the cosmic dance. As we marvel at the ways light and shadow bring the universe to life in modern media, it's worth considering how these forces can also shape our education. How can they inspire the next generation of explorers, scientists, and dreamers? In the next chapter of our journey, we'll explore the role of light and shadow in education, uncovering how these timeless forces can ignite curiosity and foster a deeper understanding of the cosmos. What lessons can they teach us, and how can they prepare us for the challenges and opportunities of the future? The answers lie in the classroom, where the echoes of the universe meet the minds of tomorrow. In classrooms around the world, light and shadow are more than just concepts, they are tools for unlocking the mysteries of the cosmos. These fundamental forces serve as gateways to understanding everything from the birth of stars to the structure of galaxies. By harnessing the interplay of brilliance and darkness, educators bring the universe to life, transforming abstract ideas into tangible, awe-inspiring lessons. Whether through models, simulations, or hands-on experiments, the study of light and shadow becomes a journey of discovery, one that sparks curiosity and inspires the next generation of astronomers, physicists, and dreamers. One of the most effective ways to teach the cosmos is through physical models. Imagine a classroom where students use a simple lamp and a globe to simulate the phases of the moon. As they move the globe around the light source, they see first, and how the moon's shadow shifts, creating the familiar crescent, half, and full moon phases. This hands-on approach not only demystifies the process, but also connects students to the celestial rhythms that have fascinated humanity for millennia. Similarly, models of solar eclipses using a ball and a flashlight allow students to explore how shadows can block the sun's light, creating moments of cosmic alignment that captivate observers on Earth. These activities turn abstract concepts into vivid experiences, making the universe feel accessible and real. Simulations take this learning a step further, offering students a chance to explore the cosmos in ways that would be impossible otherwise. With software like Universe Sandbox or online planetarium tools, learners can manipulate the positions of stars, planets, and galaxies, observing how light and shadow shape the universe on both small and grand scales. They can simulate the formation of black holes, the collision of galaxies, or even the expansion of the universe itself. These digital tools not only deepen understanding, but also foster a sense of wonder, as students realize they're interacting with the same forces that govern the cosmos. It's a reminder that the universe is not just something to study, it's something to explore, question, and marvel at. Hands-on activities, meanwhile, bring the cosmos into the classroom in a way that textbooks never could. Picture a group of students building their own spectroscopes to analyze the light from different sources, discovering how elements like hydrogen and helium leave unique fingerprints in the spectrum. Or consider a project where they create their own cosmic microwave background using simple materials, simulating the faint glow of the universe's earliest moments. These activities don't just teach science, they ignite passion, showing students that they, too, can uncover the secrets of the universe with a little curiosity and creativity. At the heart of these educational approaches is the goal of inspiring the next generation of explorers. By teaching the cosmos through light and shadow, educators are not just imparting knowledge, they are nurturing a sense of wonder and possibility. They're showing students that the universe is not a distant, untouchable place, but a dynamic, ever-changing tapestry that we are all a part of. And in doing so, they're planting the seeds for future discoveries, encouraging young minds to ask the big questions and seek the answers that will shape our understanding of the cosmos. But the impact of studying light and shadow goes beyond the classroom. For many, it's a deeply personal journey, one that changes the way they see the world and their place within it. Whether it's the awe of witnessing a solar eclipse or the quiet reflection of gazing at the stars, these experiences remind us of our connection to something greater than ourselves. They invite us to look up, to wonder, and to dream, and in doing so, they inspire us to explore not just the universe, but the boundless potential within ourselves. As we turn our attention to the personal impact of these cosmic forces, we'll explore how light and shadow shape not just our understanding of the universe, but our very sense of identity and purpose. What does it mean to stand beneath the stars, to witness the dance of light and darkness, and to feel the echoes of the cosmos within us? The answers lie in the stories of those who have been forever changed by their encounters with the universe's most fundamental forces. As I reflect on the journey of exploring light and shadow in the cosmos, I'm struck by how profoundly these forces have reshaped my understanding of the universe and my place within it. It's one thing to study the science of starlight or the physics of black holes, but it's another entirely to feel the weight of their meaning. Every time I look up at the night sky, I'm reminded that the light I see is a messenger from the past, carrying stories of stars that burned bright long before I existed. And the shadows, they're not just voids but gateways, concealing mysteries that challenge our very perception of reality. This interplay of brilliance and obscurity isn't just a scientific curiosity, it's a metaphor for life itself, a reminder that understanding often comes from embracing both clarity and uncertainty. There's a quote by Carl Sagan that has always resonated with me: "The cosmos is within us, we are made of star stuff." It's a simple yet profound idea, one that ties our existence to the very fabric of the universe. When I first began exploring the cosmos, I was captivated by the sheer scale of it all, the vastness of galaxies, the incomprehensible distances between stars, the unfathomable age of the universe. But over time, I've come to see that the grandeur of the cosmos isn't just out there, it's within us too. The atoms that make up our bodies were forged in the hearts of stars, and the light we see today connects us to the universe's earliest moments. In a very real sense, we are the universe observing itself, a living echo of its history. One of the most humbling moments in my journey came while observing a solar eclipse. As the moon's shadow swept across the Earth, I felt a profound connection to the countless generations of humans who had witnessed the same celestial dance. For a few fleeting minutes, the sun's corona shimmered like a halo, its light bending around the moon's silhouette. In that moment, I wasn't just an observer, I was part of a cosmic rhythm, a participant in a story that has been unfolding for billions of years. It was a reminder that we are not separate from the universe, but an integral part of its unfolding narrative. This journey has also taught me that light and shadow are not just physical phenomena, they are teachers. Light reveals the structure of the cosmos, showing us the intricate patterns of galaxies and the birthplaces of stars, but it's the shadows that often hold the most profound lessons. They remind us that there is always more to discover, that the universe is full of mysteries waiting to be uncovered. Whether it's the shadow of a black hole warping space-time or the faint silhouette of an exoplanet passing in front of its star, these moments of darkness are invitations to explore, to question, and to dream. Yet, as much as this exploration has deepened my understanding of the cosmos, it's also made me more aware of our shared humanity. The awe I feel when gazing at the stars is the same awe felt by people across cultures and centuries. It's a universal emotion, one that transcends language, borders, and time. And in that shared sense of wonder, I find hope, a belief that our curiosity and creativity can guide us toward a deeper connection with each other and the universe. As we turn our gaze to the future, the lessons of light and shadow will continue to shape our path. How will these forces guide our exploration of the cosmos? What role will they play in our quest to understand the universe's ultimate fate? These are the questions we'll explore next, as we delve into the role of light and shadow in shaping our future. A future where the echoes of the cosmos continue to inspire and challenge us, lighting the way forward. The study of light and shadow isn't just about understanding the cosmos, it's about shaping the future. From the way we harness energy to the tools we use to explore distant worlds, the interplay of brilliance and darkness has inspired some of humanity's most groundbreaking innovations. These forces, so fundamental to the universe, are also driving technological and scientific advancements that promise to transform our lives. Whether it's through cutting-edge optics, sustainable energy solutions, or the next generation of space exploration, the echoes of light and shadow are guiding us toward a brighter, more connected future. One of the most immediate impacts of our understanding of light and shadow can be seen in the field of optics. The development of advanced telescopes, for example, has revolutionized our ability to observe the cosmos. Instruments like the James Webb Space Telescope use mirrors and sensors designed to capture the faintest traces of light, allowing us to peer billions of years into the past. But the influence of optics extends far beyond astronomy. Innovations in lens technology have transformed industries, from medical imaging that saves lives to high-speed fiber optics that power the internet. These advancements, rooted in the study of light, are a testament to how fundamental research can lead to practical, life-changing applications. Energy is another area where light and shadow are driving innovation. Solar power, which converts sunlight into electricity, is one of the fastest-growing renewable energy sources in the world. By studying how light interacts with materials, scientists have developed more efficient solar panels that can capture and store energy even in low light conditions. Meanwhile, the concept of solar shading using structures to block or redirect sunlight has inspired architectural designs that reduce energy consumption in buildings. These innovations not only address the urgent need for sustainable energy, but also demonstrate how the principles of light and shadow can be harnessed to create a more sustainable future. Space exploration, too, is being reshaped by our understanding of these forces. Light-based technologies, such as laser communication systems, are revolutionizing how we send and receive data from distant spacecraft. These systems, which use beams of light to transmit information, are faster and more reliable than traditional radio waves, enabling real-time communication with missions to Mars and beyond. Meanwhile, the study of shadows has led to breakthroughs in navigation. By analyzing the way light and shadow interact with planetary surfaces, scientists have developed tools that allow rovers and probes to navigate unfamiliar terrain with precision. These advancements are not just expanding our reach into the cosmos, they are redefining what's possible, but the potential for future breakthroughs doesn't end there. Researchers are exploring how light and shadow can address some of the world's most pressing challenges. For example, the development of light-based therapies is offering new hope for treating diseases, from cancer to neurological disorders. By using targeted beams of light, doctors can deliver treatments with unprecedented precision, minimizing damage to healthy tissue. Similarly, the study of shadows is inspiring innovations in agriculture, where shading techniques are being used to optimize crop growth and conserve water in arid regions. These applications show that the lessons of light and shadow are not confined to laboratories or observatories. They are shaping the world we live in. As we look to the future, it's clear that the interplay of light and shadow will continue to guide our progress. Whether it's through new technologies, sustainable solutions, or groundbreaking discoveries, these forces are a source of endless inspiration and possibility. But their influence extends beyond science and technology. They also hold the key to addressing some of the most urgent global challenges of our time. How can we use the principles of light and shadow to combat climate change, improve healthcare, or ensure access to clean water? These are the questions we'll explore next as we delve into the role of light and shadow in shaping a more equitable and sustainable world. The answers, like the cosmos itself, are waiting to be uncovered. As we look to the future, the interplay of light and shadow isn't just a cosmic phenomenon, it's a practical guide for addressing some of the most pressing challenges facing our planet. From climate change to energy sustainability, these fundamental forces are inspiring innovative solutions that could reshape the way we live, work, and interact with the world around us. By harnessing the power of light and the strategic use of shadow, humanity is finding new ways to create a more sustainable and equitable future, proving that the lessons of the cosmos can have a profound impact right here on Earth. Take solar energy, for example. The sun, our nearest star, bathes the planet in an almost unimaginable amount of energy every day. By capturing even a fraction of this light, we can power homes, cities, and industries without relying on fossil fuels. Advances in photovoltaic technology have made solar panels more efficient and affordable than ever, turning sunlight into a cornerstone of renewable energy. But the story doesn't end there. Researchers are now exploring how to optimize solar energy systems by managing shadows, whether it's through smart placement of panels or the use of reflective surfaces to redirect sunlight. These innovations are not just about generating power, they're about creating systems that work in harmony with the natural rhythms of light and darkness. Light-based technologies are also revolutionizing other areas of sustainability. Consider the field of urban design, where the strategic use of light and shadow can reduce energy consumption and improve living conditions. By incorporating materials that reflect sunlight, architects can create buildings that stay cooler in the summer, reducing the need for air conditioning. Similarly, shading techniques like green roofs or strategically placed trees can block excess sunlight, creating comfortable outdoor spaces while lowering energy demands. These approaches show how the principles of light and shadow can be applied in practical, impactful ways, transforming cities into more sustainable and livable environments. But the influence of light and shadow extends beyond energy and architecture. In agriculture, for instance, understanding how light interacts with crops is leading to breakthroughs in food production. Techniques like vertical farming use controlled lighting to grow crops indoors, maximizing space and minimizing water use. Meanwhile, shadow management, such as using shade nets to protect delicate plants from harsh sunlight, can improve yields and reduce stress on ecosystems. These methods are not just about feeding a growing population. They're about doing so in a way that respects the delicate balance of our planet's resources. Perhaps most intriguing is how cosmic insights are helping us tackle earthly challenges. The same principles that govern the birth of stars and the behavior of light in space are guiding innovations here on Earth. For example, the study of light absorption in distant galaxies has inspired new ways to capture and store solar energy more efficiently. Similarly, the way shadows form around black holes has led to advancements in imaging technology, with applications in everything from medical diagnostics to environmental monitoring. It's a reminder that the universe is not just a place to explore, it's a source of inspiration and knowledge that can help us solve problems closer to home. As we confront the global challenges of our time, the interplay of light and shadow offers more than just practical solutions. It provides a mindset. It reminds us that balance is key, that every challenge has a counterpoint, and that innovation often comes from embracing both the seen and the unseen. Whether it's through harnessing the power of sunlight or using shadows to create sustainable spaces, these forces are guiding us toward a future that is both brighter and more harmonious. Yet, as we explore the practical applications of light and shadow, it's worth pausing to consider their deeper, more intangible significance. What do these forces mean for us on a spiritual level? How do they shape our sense of purpose and connection to the cosmos? These are the questions we'll explore next as we delve into the spiritual dimensions of light and shadow, a journey that invites us to look beyond the physical and into the profound mysteries of existence. The interplay of light and shadow extends far beyond the physical cosmos. It resonates deeply within the human soul, symbolizing the inner struggles, growth, and transformation that define our spiritual journeys. Across cultures and traditions, these forces have served as powerful metaphors for the eternal dance between clarity and mystery, knowledge and ignorance, and even life and death. They remind us that the universe's duality is mirrored within us, shaping our understanding of existence and our place within it. In many spiritual traditions, light is synonymous with enlightenment, truth, and divine presence. In Buddhism, the concept of bodhi, or awakening, is often depicted as a radiant light that dispels the darkness of ignorance. Similarly, in Christianity, light represents the presence of God, as seen in the imagery of Christ as the light of the world, guiding believers out of spiritual darkness. These metaphors highlight how light serves as a beacon of hope and transformation, illuminating the path toward inner peace and understanding. Yet, shadow plays an equally vital role in spiritual growth. It represents the hidden, unexamined parts of ourselves, our fears, doubts, and unresolved struggles. In the Hindu tradition, the goddess Kali embodies this duality. She is both a destroyer and a creator, her dark form symbolizing the dissolution of ego and the shadows we must confront to achieve spiritual liberation. Similarly, in Jungian psychology, the shadow self represents the unconscious aspects of our personality, the parts we often reject or ignore. Confronting these shadows is not just a spiritual practice, but a journey toward wholeness, a reminder that growth often comes from embracing discomfort and uncertainty. The balance between light and shadow is also central to the concept of transformation. In alchemy, the process of turning base metals into gold is a metaphor for spiritual enlightenment, a journey that requires both light and darkness. The alchemist's work begins in the nigredo, or blackening phase, where the material is broken down and purified in shadow. Only through this process can it be reborn into the albedo, the whitening phase of clarity and illumination. This symbolic journey reminds us that transformation is not a linear path but a cyclical process, where light and shadow work together to create something new. These spiritual dimensions of light and shadow are not just abstract ideas, they are lived experiences. Think of a moment when you faced a personal challenge, a time when the path forward seemed shrouded in darkness. It's often in these moments of struggle that we find the greatest growth, emerging with a deeper understanding of ourselves and the world around us. The shadows we confront, whether internal or external, are not obstacles but opportunities, invitations to explore the depths of our being and emerge transformed. This interplay of light and shadow within the soul reflects a broader truth that all things are interconnected. Just as the cosmos is shaped by the dance of brilliance and obscurity, so too are our lives. The challenges we face, the moments of clarity we experience, and the transformations we undergo are all part of a larger, universal tapestry. They remind us that we are not separate from the universe but deeply woven into its fabric, participants in a cosmic dance that transcends time and space. As we reflect on these spiritual dimensions, we're reminded that the journey of light and shadow is not just about exploring the cosmos, it's about exploring ourselves. It's about finding meaning in the contrasts, embracing the unknown, and discovering the light within the shadows. In the next part of our journey, we'll explore how this interconnectedness extends beyond the individual, shaping the collective human experience and guiding us toward a deeper understanding of our shared existence. What does it mean to be part of a universe where light and shadow are not just forces but reflections of our own inner worlds? The answers lie in the stories we share, the connections we forge, and the echoes of the cosmos within us all. At the heart of the cosmos lies a profound truth. Light and shadow are not just isolated phenomena, but threads in a vast, interconnected tapestry. They weave through every scale of existence, from the infinitesimal vibrations of subatomic particles to the sprawling majesty of galaxies. Imagine the universe as a cosmic web, where each strand represents a relationship between light and shadow, binding together the smallest and largest elements of reality. This intricate interplay isn't just a feature of the universe, it's the very essence of how it functions, a reminder that everything is connected in ways both visible and unseen. Consider the humble photon, the fundamental particle of light. Born in the fiery hearts of stars, it travels across billions of light years, carrying with it the story of its origins. Along its journey, it interacts with dust clouds, black holes, and even the fabric of spacetime itself, bending and shifting as it goes. These interactions create shadows, subtle distortions that reveal the presence of otherwise invisible forces. It's like a cosmic game of telephone, where light is the messenger and shadow the interpreter, translating the universe's secrets into something we can observe and understand. This interconnectedness isn't limited to the grand scale of galaxies and black holes. Even on the smallest scales, light and shadow play a crucial role. In quantum mechanics, particles exhibit wave-like behavior, creating patterns of light and darkness that hint at the underlying structure of reality. The famous double-slit experiment, for instance, shows how light, or even electrons, can behave as both particles and waves, creating an interference pattern of bright and dark bands. This phenomenon isn't just a scientific curiosity, it's a window into the fundamental nature of existence, where light and shadow reveal the dualities that define the universe. Zooming back out, this interplay shapes the very structure of the cosmos. Galaxies, for example, are not randomly scattered across the universe, but connected by vast filaments of dark matter, a cosmic web that mirrors the patterns of light and shadow on smaller scales. These filaments act as highways, guiding the flow of gas and dust that fuel the birth of stars and planets. The light from these newborn stars illuminates the surrounding darkness, creating a dynamic balance that shapes the evolution of galaxies over billions of years. It's a reminder that the universe is not a collection of isolated objects, but a symphony of interconnected forces, each playing its part in the grand cosmic dance. But what does this interconnectedness mean for us? On a fundamental level, it underscores our own connection to the universe. The atoms in our bodies, the light that allows us to see, and the shadows that give our world depth, all are part of this cosmic web. We are not separate from the cosmos, but deeply woven into its fabric, shaped by the same forces that govern the birth of stars and the dance of galaxies. This realization invites us to see ourselves not as passive observers, but as active participants in the universe's unfolding story. As we marvel at this web of light and shadow, we're left with a tantalizing question. How do these forces shape not just the physical universe, but also our creativity and understanding? In the next chapter of our journey, we'll explore how light and shadow inspire art and science, bridging the gap between the cosmos and human expression. What secrets do they hold about the ways we see, create, and discover? The answers lie in the interplay of brilliance and obscurity, a partnership that continues to illuminate both the universe and our place within it. Art and science, often seen as separate realms, are in fact deeply intertwined, especially when it comes to the study of light and shadow. These forces, so fundamental to both fields, have inspired countless collaborations where creativity and discovery meet. Artists and scientists alike are drawn to the interplay of brilliance and obscurity, finding in it a shared language that transcends disciplines. Together, they create visualizations of cosmic phenomena that not only educate but also evoke a sense of wonder, bridging the gap between the analytical and the imaginative. One of the most striking examples of this collaboration is the visualization of black holes. For decades, these mysterious objects were the subject of theoretical equations and abstract models. But in 2019, the Event Horizon Telescope team unveiled the first ever image of a black hole, a feat made possible by the combined efforts of scientists, engineers, and artists. The raw data, collected from telescopes around the world, was transformed into a visually stunning image through a process that required both technical precision and artistic interpretation. The result, a glowing ring of light surrounding a dark void, was not just a scientific breakthrough, but a work of art that captured the imagination of millions. Similarly, NASA collaborations with artists have brought the cosmos to life in ways that raw data alone cannot. Through initiatives like the NASA Art Program, painters, sculptors, and digital artists have created works inspired by space missions, from the fiery launch of rockets to the serene beauty of distant planets. These pieces do more than illustrate scientific concepts. They evoke the emotions and awe that come with exploring the unknown. For instance, the swirling colors of a nebula, as seen through the lens of the Hubble Space Telescope, have inspired countless paintings and digital art pieces, each one offering a unique interpretation of the same cosmic phenomenon. In this way, art becomes a bridge, connecting the cold, hard facts of science to the warmth of human experience. But the intersection of art and science goes beyond visualization. It also drives innovation. Take the field of astrophotography, where photographers use long exposures and specialized techniques to capture the faint light of distant stars and galaxies. These images, often breathtaking in their beauty, are more than just photographs. They're tools for discovery. By revealing details invisible to the naked eye, astrophotographers contribute to our understanding of the cosmos, proving that creativity is not just a complement to science but a vital part of it. The role of creativity extends even further in projects like the Cosmic Reef, a visualization of two neighboring nebulae created by NASA, a Goddard Space Flight Center. Using data from the Hubble Space Telescope, scientists and artists work together to craft a three-dimensional model that brings these distant clouds of gas and dust to life. The result is a vivid, immersive experience that allows viewers to fly through the nebulae, exploring their intricate structures and vibrant colors. This fusion of art and science doesn't just make the cosmos more accessible, it deepens our connection to it, reminding us that the universe is not just a place of facts and figures, but a source of endless inspiration. As we reflect on these collaborations, we're reminded that the study of light and shadow is not just about uncovering the secrets of the cosmos, it's about sharing them in ways that resonate with everyone. Whether through a painting, a photograph, or a groundbreaking visualization, the interplay of art and science invites us to see the universe not just with our minds but with our hearts. And as we turn our gaze to the legacy of light and shadow, we'll explore how these forces have shaped human history, culture, and our ongoing quest to understand the cosmos. What lessons can we learn from this enduring partnership, and how will it guide us as we continue to explore the universe's most profound mysteries? The answers lie in the echoes of the past, waiting to illuminate the path forward. The story of light and shadow is not just a tale of the universe's past, it's a living, breathing legacy that continues to shape the cosmos in ways both profound and subtle. From the birth of the first stars to the formation of galaxies, these forces have been the architects of our universe, carving out its structure and guiding its evolution. They are the echoes of creation, the silent witnesses to billions of years of cosmic history, and their influence will endure long after the last star has faded. But this legacy is more than just a scientific phenomenon. It's a heritage that connects us all, a reminder of our shared origins and the delicate balance that defines existence. Think of the cosmic microwave background, the faint glow of light left over from the Big Bang. It's a snapshot of the universe in its infancy, a time capsule that preserves the conditions of its earliest moments. This ancient light, still detectable today, carries with it the story of how everything began, a story written in the language of photons and shadows. It's a reminder that the universe has a memory, one that stretches back to the very beginning of time. And just as this light has traveled billions of years to reach us, it will continue to echo through the cosmos, shaping its future in ways we can only begin to imagine. But the legacy of light and shadow isn't confined to the distant past. It's also being written in the present as new stars are born and galaxies collide. Each nova, each supernova, adds its own chapter to this ongoing narrative, leaving behind ripples of light and shadow that will influence the universe for eons to come. Even the shadows cast by black holes, those enigmatic voids where gravity reigns supreme, are part of this legacy. They bend and distort the light around them, creating patterns that reveal the presence of invisible forces like dark matter. These shadows are not just absences of light, they are active participants in the cosmic dance, shaping the universe in ways that are both mysterious and profound. As we marvel at this enduring legacy, we're reminded of our responsibility to preserve it. The light and shadow we observe today are not just scientific curiosities, they are a cosmic heritage, one that belongs to all of humanity. By studying and protecting this heritage, we ensure that future generations can continue to explore and learn from the universe's most fundamental forces. This isn't just about building bigger telescopes or launching more missions, it's about fostering a sense of stewardship, a recognition that the cosmos is a shared resource that deserves our care and respect. Yet, the legacy of light and shadow is not just something to be preserved, it's also a source of inspiration. These forces remind us that the universe is a place of endless possibility, where even the darkest corners hold the potential for discovery. They challenge us to look beyond what we know, to explore the unknown, and to seek out the light hidden within the shadows. In doing so, they invite us to dream, to imagine, and to hope, a theme we'll explore further in the next chapter of our journey. How do light and shadow inspire hope, not just in the cosmos, but in our own lives? The answers await, where the echoes of the universe meet the boundless potential of the human spirit. In the vast tapestry of the cosmos, where light and shadow dance in an eternal rhythm, there lies a profound truth. Even in the deepest darkness, there is always a glimmer of light. This interplay of brilliance and obscurity isn't just a cosmic phenomenon, it's a universal metaphor for hope and resilience, a reminder that even in our darkest moments, we have the capacity to find light. Across history, literature, and personal stories, this theme has echoed time and again, offering solace and inspiration to those who face adversity. Consider the story of Anne Frank, a young girl who, during one of humanity's darkest chapters, found light in the pages of her diary. Hidden away in the shadows of World War II, she wrote not of despair, but of hope, of her belief in the goodness of people, and her dreams for a brighter future. Her words, preserved in the face of unimaginable hardship, remind us that even in the bleakest circumstances, the human spirit can shine with unwavering resilience. It's a testament to the power of light, both literal and metaphorical, to guide us through the shadows. Literature, too, is rich with this theme. Take J.R.R. Tolkien's The Lord of the Rings, where the journey of Frodo and Sam through the dark land of Mordor is a powerful allegory for perseverance. Even as they face overwhelming odds, it's the small, steadfast light of the Phial of Galadriel, a gift of starlight that helps them navigate the perilous path. This light, though fragile, becomes a symbol of hope, a reminder that even the smallest glimmer can illuminate the way forward. Tolkien's tale resonates because it mirrors our own struggles, showing us that light, no matter how faint, can be a source of strength. Personal stories of resilience also reveal this truth. Think of the countless individuals who, after experiencing loss or hardship, find ways to rebuild their lives. Whether it's a survivor of illness who becomes an advocate for others, or someone who turns a personal tragedy into a mission to help their community, these stories show that light can emerge from even the deepest shadows. They remind us that darkness is not an end, but a beginning, a space where new possibilities can take root and grow. This concept is mirrored in the cosmos itself. When we look at the night sky, we see not just darkness but countless points of light stars that have burned for billions of years, some of which no longer exist, yet whose light continues to reach us. These celestial echoes remind us that light endures, even in the face of time and distance. They teach us that our own struggles, though they may feel overwhelming, are part of a larger, interconnected story, one where light and shadow are always in balance and where hope is never truly extinguished. As we reflect on these stories, both terrestrial and cosmic, we're reminded that the journey of discovery, whether it's exploring the universe or navigating the challenges of life, is not just about finding answers. It's about finding meaning, about understanding that the interplay of light and shadow is not just a physical reality, but a guiding principle. It's what drives us to keep searching, to keep believing, even when the path ahead seems uncertain. And so, as we continue our exploration of the cosmos, we'll delve into how this journey of discovery shapes not just our understanding of the universe, but our place within it. What does it mean to seek out the light, to embrace the shadows, and to find hope in the unknown? The answers lie in the stories we tell, the questions we ask, and the endless curiosity that propels us forward. The journey of exploring light and shadow in the universe is much like navigating a vast, uncharted ocean. It's a voyage filled with moments of awe, challenges that test our limits, and discoveries that reshape our understanding of existence. From peering into the fiery hearts of stars to unraveling the enigmatic shadows of black holes, this odyssey has been one of relentless curiosity and unyielding perseverance. Each step forward has revealed not only the secrets of the cosmos, but also the resilience and ingenuity of the human spirit. What began as a simple act of looking up at the night sky has transformed into a quest to decode the universe's most profound mysteries, a journey that continues to inspire and humble us. Along the way, we've faced challenges that seemed insurmountable: the faint whispers of light from distant galaxies, the elusive shadows cast by invisible dark matter, and the mind-bending physics of black holes have all pushed the boundaries of our knowledge and technology. Yet with each obstacle, we've found new ways to innovate, to adapt, and to push further. The construction of powerful telescopes, the development of cutting-edge imaging techniques, and the collaborative efforts of scientists around the world have all played a role in overcoming these hurdles. These triumphs are not just milestones in science, they are testaments to what we can achieve when we refuse to give up, even in the face of the unknown. But the journey isn't just about the challenges or the victories, it's about the lessons we've learned along the way. One of the most profound realizations is that the universe is far stranger and more wondrous than we ever imagined. What we once thought were empty voids are now known to be teeming with dark matter and dark energy. The shadows we once dismissed as mere absences of light have become gateways to understanding the cosmos' deepest secrets. These discoveries remind us that there is always more to uncover, that the universe is a place of endless possibility, and that our quest for knowledge is never truly complete. At the heart of this journey lies curiosity, the driving force that propels us forward, even when the path is uncertain. It's this innate desire to explore, to question, and to understand that has led us to this point. And it's this same curiosity that will guide us as we venture further into the unknown. Whether we're studying the birth of stars, the formation of galaxies, or the nature of spacetime itself, it's this spark of wonder that keeps us moving, keeps us searching, and keeps us dreaming. As we near the end of this cosmic odyssey, it's worth reflecting on how far we've come, and how much farther we have yet to go. The interplay of light and shadow has not only shaped the universe, but also our understanding of it, revealing a cosmos that is both breathtakingly beautiful and profoundly mysterious. In the final section of our journey, we'll bring together these themes, exploring how the dance of light and shadow connects us to the universe and to each other. What does this cosmic symphony mean for humanity, and how does it inspire us to keep exploring, keep learning, and keep reaching for the stars? The answers await, where the echoes of the cosmos meet the boundless potential of the human spirit. As we bring our journey to a close, let's take a moment to reflect on the profound dance of light and shadow that defines our universe. From the fiery birth of stars in stellar nurseries to the enigmatic silhouettes of black holes, we've explored how these forces shape the cosmos in ways that are both breathtaking and mysterious. Light, with its radiant energy, reveals the structure of galaxies, the birth of planets, and the echoes of ancient cosmic events. Shadow, often overlooked, plays an equally vital role sculpting the universe's depth, concealing its secrets and revealing the invisible forces that govern existence. Together, they form an eternal rhythm, a cosmic symphony that echoes across space and time. The concept of interstellar echoes is more than just a scientific idea, it's a reminder of the universe's interconnectedness. Every beam of light, every shadow cast, tells a story of creation, transformation, and evolution. These echoes are the whispers of stars long gone, the ripples of galaxies colliding, and the subtle distortions of spacetime itself. They remind us that the universe is not just a collection of isolated phenomena, but a web of relationships, where every element influences and is influenced by the whole. It's a tapestry woven with threads of brilliance and darkness, each one essential to the grand design. But what does this mean for us here on Earth? It means that we, too, are part of this cosmic dance. The atoms in our bodies, the light that fills our days, and the shadows that stretch across our world are all connected to the stars above. We are not just observers of the universe, we are participants, shaped by its forces and contributing to its story. The light we see today, the shadows we study, and the mysteries we unravel are all part of a legacy that stretches back to the Big Bang and forward into the unknown future. As we stand beneath the night sky, let's take a moment to marvel at the beauty and complexity of the universe. Look up and see the stars, not as distant points of light, but as beacons of possibility. Each one is a reminder of the endless curiosity that drives us to explore, to question, and to dream. The dance of light and shadow is not just a cosmic phenomenon, it's an invitation. An invitation to look beyond what we know, to embrace the unknown, and to find meaning in the interplay of brilliance and obscurity. So, here's our call to action. The next time you step outside on a clear night, take a moment to gaze at the stars. Let their light fill you with wonder, and let the shadows remind you of the mysteries that still await. Ask questions, seek answers, and never stop exploring. The universe is vast, but it's also deeply personal, a place where science meets imagination, and where the echoes of the cosmos resonate within us all. Let's continue this journey together, with curiosity as our guide and the night sky as our map. The dance of light and shadow is eternal, and so is our quest to understand.